We are now proceeding with the topic, as there's still a lot of things to actually cover up. So one thing that you need to understand is that we're actually having, I'm just gonna make an example now. We're actually having this. Okay, my diagram is not that visible, but it's okay then. It means to say I must draw it. So yeah, that will be our example number 1 for today. So on this example, what basically they're giving us a Cartesian plane, which is like this. And then they're also giving us a circle. So that is the circle that we are actually given. Remember that this is the y-axis, and then that is the x-axis. That's what we are actually given. And then here they're telling us that that's point P. If I were to ask you, this question, this circle, is it centered at the origin or not? And justify your answer. This circle, is it centered at the origin or not? And justify your answer. Why? In order to support your statement, why are you saying so? I'm listening, guys. It's a question that I'm putting on the floor. So this is A into minus 29.
It looks like it's centered in the origin.
Why are you saying that? Okay, the circle is not centered at the origin simply because what I told you to say when the circle is centered, no, because it does not start at 0 and 0. That's very correct. So I just actually told you to say for a circle to be centered at the origin, it means to say the coordinates of the center must, when the circle is centered at the origin, it means to say the coordinates of the center must be 0 and 0. But with regards to the question that I've just asked now, this circle is not centered at the origin. Hence, the coordinates of the center are not going to be 0 and 0. So they're saying in the sketch alongside, in the sketch alongside, in the sketch alongside, so they're saying in the sketch alongside the equation of the circle, comma, the equation of the circle, the equation of the circle is, and then I'm going to write the equation, right? So this is the equation. It's a continuation part is, and then they give you the equation, which is given as what? Which is given as x squared. So that is the equation that basically we're given. Ne? It's one statement. So it's gonna be x squared plus y squared plus minus 4x minus 6y minus 14 is equals to 0. So that's what they actually are given. And for you to be able to master this, it needs you to know the basic that I've just showed you. And then the saying P is the center of the circle. You can actually see, though I didn't write that information. And then They're saying AQ is a tangent to the circle at Q. So AQ is a tangent because a tangent is a line that touches the circle at one distinct point. And then for number 1, they are saying determine the coordinates of P. So as we look at determining the coordinates of P, does it represent the center? Yes, P represents the center. And then for you to get the coordinates of the center for that P, that's because of, even though they didn't tell you, you can actually see that P is not centered at the origin. It means to say the coordinates of P, it will be always X and Y. And that X, it will be a positive 1, as well as that Y, it will be a positive 1. And then the question will arise, how do I get the coordinates of P that represents the center? It basically means to say you're going to write the equation as it is, which is x squared plus, and then you write y squared minus, that is 4x minus 4x. And then after that, you're going to say minus 6y, right? And then minus 14, it's equals to 0. So remember on the previous session, I've taught you how do you get the coordinates of the center of this. Yes, it means to say I'm going to complete the square. So you're going to say x squared minus 4x, and then you add half of the middle term, you square it, plus half of the middle term is going to be what? Negative 2. You square it, you subtract half of the middle term, minus 2, all squared. So you add half of the middle term, you subtract it, just like that. And then after that, I'm going to say plus y squared. I'm going to say plus y squared minus 6y. And then you add half of the middle term, you square it. Half of the middle term, which is going to be negative 3. You square it, subtract half of the middle term, which is negative 3. You square it. And then lastly, we have negative 14 there. So we'll say minus 14 is equals to 0. So now as you complete the square, we know that we're going to have x minus 2 all squared, right? And then that will be minus negative 2 all squared, it's 4. And then plus, with regards to that, completing the square, we know that we're going to have y minus 3. And then we square it. So that will be minus 9 minus 14 is equals to 0. And then from here, you're going to say x minus 2 all squared plus bracket y minus 3 all squared. So the next step is you now taking this part. Minus 4, minus 9, minus 14. You do it on the calculator. Let's now calculate minus 4, minus 9, minus 14.
Minus 27.
Yes, it's correct. Minus 27. Then you say equals to 0. And then this basically means to say, remember the equation of the standard equation of the circle. It's always going to be x minus a all squared plus bracket y minus b all squared, it's equals to r squared. And then in this case, you understand to say, you're going to write this as what? As x minus 2. So Yakil is saying p is 2 and 3. Yes, you are correct, Yakil. And then you're going to say all squared plus, that will be y minus 3 all squared. It's equals to, take that negative 27, you transpose it on the other side, it changes the sign to become positive. And then with regards to that, it basically means to say, as you now look at this part, remember the coordinates of the center, they're going to be represented by what? It's one and the same thing with me saying it's x and y take in consideration that that value of x is going to be +1, as well as that value for y is going to be +1. So with regards to that, it means to say, now when you look at your center, because your center it's always going to be A and B, it means to say the coordinates of the center here it's going to be +2 together with 3. Then if the question says they also want the radius, you're gonna say r² equals to 27. Therefore, the value of r,
3.
it's what?
3 square roots of 3.
So what is square root of 27? It's 3√3.
Yes.
Okay, 3√3. But this one, you just use it based on what I was just teaching you. So the first question, it wanted us to find the coordinates of the center, of which, guys, that's how you find the coordinates of the center, which is this one. So our center is 2 and 3. So one thing that you must also remember is that when you look at this part, it's very important. It's part and parcel of what you are gonna get in an exam, because I've just elaborated to say, you being grade 12, they can't give you the equation of a circle, x² plus y² is equals to r², that is centered at the origin. It's easy like that. They want you to find maybe an equation. Nah, you're gonna get such whereby they give you that long equation simply because they will want you to find the coordinates of the center, like what we did here, because they understand that a lot of you guys, you're gonna make mistakes with regards to completing the square. So that's how basically you get the coordinates of P. And then in continuation with the very same question, the second part, or the B part, I'm not gonna write the whole question, but I'm just gonna explain what you need to do. So they want the length of AQ. So they want the length of AQ. So when I speak about length, it simply means to say you have at least an understanding of what I want us to do, because length has to do with us speaking about distance. Let me rather write it. So they want us to find the length of AQ. Any idea on how basically we're gonna find that? So it means to say, with regards to that, always there is a very reason why they wrote this. On the last part of the information, is just that I didn't write it here. They actually said AQ is a tangent to the circle at Q. So when they're saying it's a tangent to the circle at Q, at least you understand that the tangent is always perpendicular to the radius, at the point of contact. So the first thing that you're going to do, since they want you to calculate the length of AQ, you want to draw AP. We'll say draw AP and AQ. So this is what you're going to do. We'll say draw AP and QP. So what basically you're gonna do, you're gonna go to the diagram and then let's draw AP. So remember, A is this point right here. To those who don't see it, is this point right here. So when I'm saying draw AP, it simply means to say we're gonna draw this using our dotted lines like that, and then as well as we're gonna draw what? QP. So look at that. So these are things which you need to know. After drawing that, you have an understanding to say, oh, that AQ is a tangent, and a tangent is always perpendicular to the radius. When you look at QP, even though they didn't tell you, QP, it's a radius because it's a line from the center P to the circumference of the circle. And just because of you understand that that is a radius, just because of on the second part of the statement, they actually told you to say AQ is a tangent to the circle, and then a tangent is always perpendicular to the radius or diameter at the point of contact. That's when now you can try to conclude or give them a go-ahead to say, you know what, this angle right here is going to be 90 degrees because a tangent is always perpendicular to the radius, which is represented by QP at the point of contact. And then after that, you now, it will make your work to be much easy for you to calculate the length of AQ. Why am I saying it now makes your work to be much easy to calculate the length of AQ? It means to say, since now r squared is equal to x squared plus y squared, do we have the coordinates of what? Of Q in that case? We don't have them. So AP squared is equal to who can tell me what are we gonna do here? Any suggestion? Any suggestion? Okay, since there's no suggestion, it means to say we can continue. So what basically you're gonna do? Let's find AP squared. And then for you to be able to find AP squared, you go to the diagram. You check where when I'm saying let's find AP squared, you look at AP. So AP is equals to the what? It's equals to the hypotenuse side because that's the longest side on the triangle. Ne? So what basically you can do, you can write it like this. I just want to write it like this so that it's visible. So you can just say the distance of AP. Remember now we are having our coordinates P. So since we are having the coordinates of P, which they represent the center, which is going to be 2 and 3, you're going to write them here. Do you get to see that? And then on the other hand, now it means to say AP, we can use what? We can say AP is equals to you saying the distance of what? Of -2 minus 2 all squared plus 9 minus 3. So these coordinates, I'm just taking them from the coordinates of A as well as the coordinates of P right there. And then we know that this is going to give us what? That's going to give you 52 if you were to actually solve it. And then with regards to that, now we're going to say QP squared. It's equals to. So with regards to QP, look at QP again. So when you look at QP, how can I best put this? So when you look at QP, yeah, I was just looking for the weight. So when you look at QP, Cupid represents R. Let me show you how. So Cupid is representing R because R represents the radius. Why am I saying Cupids represent R? It's because of when you look at R, it's a line from the center to the circumference of the circle. From point P to point Q, that's gonna be our R, which is the radius. Do you get to see that? So here you can just say QP, it's representing your radius, just like that. Of which here, for QP, we're gonna get 27. And then,
Sir,
yes.
please state the reason again, having to explain why QP is equal to radius.
Okay. QP, let's go to QP. This is Q, this is P. Are you happy?
Yes, sir.
Okay, cool. And then since that is QP, you ask yourself a question. Now we are happy with QP sharp. Since QP is from center P to the circumference point Q, it means to say a line from P to Q, we call it R, which is the radius. All of us, we know that the radius is a line from the center of the circle to the circumference of the circle, from point P to Q. That's why here I'm saying QP is the same as R, because when you're looking at Q, when you're looking at P, it means to say the other one is at the center, the other one is as the circumference, then it means to say it will be the radius, because the radius is a line drawn from the center to the circumference of the circle. That's why here, with regards to me knowing that to say that is going to be QP, like this, it's going to be R. Why is this R coming from? It's a radius. Do you get to see that? So you're going to have QP squared is equals to R squared is equals to 27. And then from there, lastly, what you can basically use, since they wanted us to find the length of AQ, it means to say you can now use what? You can now use the theorem of Pythagoras, because we normally use the theorem of Pythagoras only in a right angle triangle. So it means to say if you want to use the theorem of Pythagoras, you will simply say in triangle what? In triangle APQ, what happens? The hypotenuse side squared, which is represented by what? By AP squared. It's equals to the sum of the squares on the other two sides, which is going to be QP squared plus AQ. All squared. You get to see that. And then from here, it's a matter of you now substituting. But taking in consideration that when you look at AP, look at AP, look at QP, look at AQ. So it basically means to say now, what you can do, because they want you, remember, they want us to find, what was it, AQ? Yes, they want us to find AQ. So when you look at AQ on the diagram, is that line which is represented by tangent, right? So what you are going to do, you can basically rewrite this as what? As AQ squared it's equals to what? AQ squared is equals to AP squared minus what? QP squared. So it doesn't matter whether you write it the way I wrote it or you just write it like this. The main important aspect is you making sure that you adhere to mathematical rules. Ne? So the reason, and again, each and every statement should be accompanied by the reason. So here what you can just basically write, you can just say tangent AQ is perpendicular to what? It's perpendicular to the radius QP. Radius QP, which is according to the theorem of Pythagoras, which says the hypotenuse side squared is equal to the sum of the squares on the other two sides. And then from here, what basically you can do, you can just say AQ squared, it's equals to, now your AP squared is going to be 52 minus that QP, which we got, which is this one right here, 27. Then from here, what basically you're going to do, you're going to say, therefore, AQ squared is equals to, then you subtract 52 minus 27. I think we're going to get 25. So let's check this 25. I want to show you something. So that 25 is AQ squared. So when you remember the question, it says find the length of AQ. So just because of this, it's hypotenuse, this is AQ squared. As we don't want AQ squared, we simply want AQ. So it means to say you're going to have AQ squared, it's equals to 25. And then if that's the case, it means to say you introduce a square root both sides, and then here it will be plus minus, then you write the square root, because math says what you do on the left hand side, you also do it on the right hand side. Then square root cancels 2. Therefore, AQ is equals to 5. It's equals to 5 what? 5 units. Why am I saying 5 units? Yes, there was 5 units. It's because of they say find the length of AQ. So it means to say, when you go back to the diagram, the length of AQ should be 5, the whole distance here. It should be 5. You must know this by heart. It should be 5. And then this one is going to be R, of which I've just showed you how do you get that. Your R is going to be 3 right there. And then, yeah, that's how basically we solve this actually question. Any questions?
No, sir.
Yeah. Do you all understand?
Yes.
Okay, cool. So it means to say now we are continuing. I'm still gonna give you work. Welcome to analytical geometry. At least today I've taught a lot of things. We are still even pushing. Yeah. Welcome to grade 12. So now what basically we're gonna do, we're gonna be speaking about what? Let's do like this. I'm just looking for this thing of typing, but I think it types with black. Okay, I'll just read the statement. So what I wanted to write here is the relationship between circles and a point. So this is just a subtopic under circles. Relationship between circle and points. Between a circle and a point. So this one's typical exam question. You must know them by heart. It's a typical exam question. In what regard? So they will say prove that the circle it's inside, or prove that it touches the circumference, or it's outside. So one thing that you need to understand with regards to this, I'm just gonna try to explain it as short as I can so that you can understand what basically do I mean with regards to that. So here it's always gonna be the center. And then there will be a distance that is going that direction. So reset, do you forfeit marks if you don't write the reason? Not really, because this is just analytical geometry. But you can just write them for you to be on the safe side as well. Ne? So we all know that a line from the center to the circumference of the circle, we show it with that R that represents what? That represents the radius. Ne? And then with regards to this, we're gonna also have what? Our D, which is the line from the center meeting at least halfway right there. This basically means to say that is gonna be your D. So with you now having learned that, it means to say, we're gonna say it's only in the same thing with you saying let the radius be R. And then secondly, with regards to this, you need to understand that if D, let me write it properly. If D is less than the radius, ne, then the point is inside the circle. Then the point is inside the circle. the point is inside the circle. So Awana, it's very important that you must know this, because they will say that prove that the point is inside the circle. For you to prove that the point is inside the circle, that's when now you're proving Uti D is less than R. To those who don't know, though we are doing maths, it simply means to say this D stands for distance. And then this R stands for the radius. Do you get to see that? So if you can prove that the distance is less than the radius, then the point is inside the circle. So it basically means to say, 𝗏𝗏, for this situation or for this thing to take place, always if the distance, which is represented by that green line on the circle, is less than the radius, then the point is inside the circle. So that's how basically you're gonna prove this. Any question? Any question? So we also have another one under the very same subtopic. So this one, it's very interesting, simply because of we are having a circle from the center to the circumference of the circle. So that line we call it a radius. And then we also have another one right here, which is from the center to the circumference as well. So the yellow one, we'll just say it's D, that represents the distance. And then the what? The other one, we call it R. So for this to happen, we know that if the distance is equals to the radius, you can actually see from the diagram to say 𝗏𝗏, the distance is equals to the radius. So if the distance is equals to radius, then the point is on the circumference of the circle. The point is on the circumference So if you can prove that the distance, because I told you to say D represents distance. If you prove that the distance is equal to the radius, then it means to say you are on the right track. If D is equal to the radius, then the point is on the circumference of the circle. So they're gonna tell me to say prove that the point is on the circumference of the circle. Never ever say I never taught you, because you'll come across these questions. Trace how I teach. They will say prove that the point is on the circumference of the circle. Then you find a lot of learners failing that simply because they don't know how to prove that. So for you to be on the safe side, how do you prove that the point is on the point is on the circumference? It means to say if you can prove that the distance is equal to the radius, then it means to say that it lies on the circumference of the circle. So that's one thing that you must know. And then lastly, amongst the relationship between a circle and the endpoint, we also have another a good circle, which I'm just gonna draw it here. This will be the last one for under the relationship between a circle and a point. And then you find that this is your distance. Also trace how I draw this diagram so that you don't make a mistake. Ne? That one, it protrudes on the other side. And then we are also having the radius, which we know that will be the distance from the center to the circumference of the circle. So the yellow part is represented by the radius, And then the blue part is represented by the distance or the overall distance. So with regards to this, it means to say D, which represents the distance, must be greater than what? Must be greater than the radius. So in that case, it simply means to say, if, I can now write it like this. If what? If the distance with a small letter d, it's greater than the radius, it means to say the point is outside the circle. The point is outside the circle. The point is outside the circle. So that's how it is. So when you look at this diagram, you can actually see that this blue zone, which is this one right here, this blue zone, you can actually see that vele it's greater than the radius. Hence, it means to say the point is outside the circle. That's why you must not be surprised when you see this point that is outside the circle, just like that. So that's how basically we work with these guys. It's very important that you practice because practice makes perfect. So if you can master all of this, what I've just told you, I think you'll be on the safe side for now. Of which the three diagrams, they fall under the relationship between a circle and a point. Any question, guys?
No, sir.
Did you all understand?
Yes, sir.
Okay, cool. It means to say if there's no more question, we are done. Yakil is saying yes, sir. It means to say we are done for today. We are done for today. Thank you so much for joining, guys. I really appreciate you all. Let's continue practicing.